Yesterday we drew the parabola, the quadratic function, and we also started with the hyperbola. We saw that when we want to draw the hyperbola, we can get the shape from the A value. That's determining in which quadrants they are. We find the Y-intercept by letting x be equal to 0. Was that? Oh no, first we got the asymptotes. First we got the asymptotes, the vertical asymptote. Remember, p value with a negative. Q value just as it is. Then we got the Y-intercept by letting x be equal to 0. We got the X intercept by letting y be equal to 0, and I showed you that this one has a bit more of some maths calculation. It's got some more calculation to it. So just be careful when you do that. The big trick is your unknown will be in the denominator. When it's in the denominator, you swap it with the answer without changing any signs. The whole thing just swaps with the answer, and then you simplify it. Then we had a look at the asymptotes. So it's the whole equation without the a value, simplified. And then the whole equation without the a value, but a negative in front of the x and the p, and it multiplies in, simplified. Then you've got the axis of symmetry. So we still need to draw it. Let's quickly take out our pencil and our ruler. As I said to you, we are not going to waste time drawing or measuring and going on. I want you to take a look at your two axes, your two asymptotes. The one is at x negative 2, okay? So that means your graph has been shifted left, né? And the other one is at 3. That means the graph has been shifted up. Okay, just for you to do some planning on your Cartesian plane. Okay, I'm going to start plotting. The first one, always you start with the asymptotes. The first asymptote is x equal to negative 2. This is the x-axis. The x-axis must be cut at negative 2. And then you write it in x equal to negative 2. You all understand? Nothing difficult? Then you take the y asymptote. It cuts the y-axis at 3. And then you name it y equal to 3. Those would be the first marks allocated when I mark it. Katleo, why are you frowning? Trying to see. Must I make it a bit larger? But you've got the answers there. You've got the asymptotes. X negative 2, y 3. Okay, next I go and look for the y-intercept. So the y, or before I do the y-intercept, just quickly look at what we said the shape is going to be. What is the shape? Negative. Therefore, in which quadrants do I expect it to be? Second and fourth. So if I get a number plot somewhere here or there, it's a mistake. Okay. you probably more likely made a mistake with the X and the Y-intercept than reading the shape. Because positive is first and third, negative is second and fourth. There's not really a mistake you can make if you know your work. Okay. But you can make a mistake with a calculation. So the Y-intercept is at 0 and 1.5. So that will be there. And the X-intercept is at -1 and 0. Those intercepts, you must please write them as a coordinate. 0 and 3/2. And this one you write as -1 and 0. So can you see when I look at the shape of this graph, the 2 points are in the correct quadrant? You see? So I can just join them. I am not going to go and calculate some more points because I know my shape. I know what a hyperbola looks like. And then the other one will be in this quadrant. Do you see there are no critical points there? Nothing. But I try to make it more or less the same shape. You don't normally have to draw in the axis of symmetry. They normally just ask you for the equations of the axis of symmetry. But I just want to show you so that you can see if I were to draw a line. Remember, this thing is not drawn on scale, ne? Right there, somewhere there. Do you see it makes sense that the top and the bottom will fit on each other? And it's a straight line that cuts through 5 and 2, -3, -4, -5. Perfect. Okay, do you see that? Because the gradient is 1, therefore it will cut at 5 and at -5. Alright, and then the other one, if I were to draw it this side, it crosses through there. That's the other axis of symmetry. Do you see it cuts at 1 on the y-axis? And the equation was -x + 1. So it just works out. Something that I just want to focus your attention on. If I had given you the graph and I give you the value of that coordinate right there, that would be -2 and 3. -2 and 3. If I give you that coordinate, listen to what I'm saying. I've given you the value of the two asymptotes together. Do you see that? If I tell you that's the point -2 and 3, that means your one asymptote is x equal to -2. The other asymptote is y equal to 3. Make sense? Okay. Now we are going to draw an exponential function. Although we've drawn many exponential functions now, you actually now know how to draw the exponential function. But let me get a nice one for you. I want you to think about this for a minute. And then I want you to use your hand and show me what this graph would look like. 2, the base is 2 to the power of x. Remember, it can be plus p and q, whatever. You can even write there plus p plus q. Doesn't matter how it has been translated in other ways. If I see a base of 2, what does that mean? It's 1 times 2. Show me with your hands what this graph will look like. I see a few of you that know. The asymptote will be below it. The graph will start at the bottom and it will go up. Okay. If it was negative 2 to the power of x, it can be plus p and plus q. Doesn't matter what happens there. This graph is going to be at the top or at the bottom of the asymptote? Bottom of the asymptote. Okay, and what will it look like? Very good. It will start at the bottom and go to the top. This is a reflection of this one in the asymptote. So if you are unsure, you only need to know this one and this one. And then you will know when it's negative, it's a reflection. You do that reflection in your mind. Okay. If it's a half, will it be at the top or the bottom of the asymptote? At the top. And what will this graph look like? Good. Starting at the top, going down. We call this increasing. This one, increasing. This one, decreasing. And when it's negative a half, will it be at the top or the bottom of the asymptote? Bottom. And what will it look like? It will be this reflection. So in other words, no, I didn't reflect this one right. Hi, Bo. Sorry. This one reflected will look like this. Sorry. And this can be plus P and plus Q as well. Now there's one more trick I just want to make you aware of. Okay? If they give you the sum and it's 2 to the power of negative x, what is the base? 2. So what will this one shape look like? If you get a graph y equal to 2 to the power of negative x plus p plus q, what will it look like with your hands? Now I want you to remember. Think back. What does a negative exponent mean? Fraction, eh? So do you agree that this is actually a half to the power of x? So what will this one look like? They will catch you. You moet wakker wees. Okay. If it was a half to the power of negative x, swap around. Okay. You guys understand what I'm saying here? All of you. Princess? Was that a yes? Sure. When I have a negative exponent, it becomes a fraction for that exponent to become positive. That means this base is not 2, it's a half to the power of x. Okay. Which one of these 4 do you want to draw? We drew a lot of 2x, no? To the power of x. On that back of that page. We drew many of them. Negative half. Okay. Let's make it h of x equal to negative a half to the power of x minus 1 minus 1. Okay. When we draw the exponential function, we need to know the shape. We need to know what we're expecting, eh? Okay. Does this one have asymptotes as well? No, it has an asymptote. Only one. Okay. Hyperbola has 2. Exponential has 1. The next one is the Y-intercept. Do you guys remember yesterday I said it will always have a Y-intercept, but it might not have an X intercept. Okay. So you put in X intercept, but in brackets maybe. You will understand why I'm saying maybe, ne? And this one, it doesn't have an axis of symmetry. It's not somewhere that I can cut that graph where the top and the bottom or the left and the right will be the same. Okay. I'm going to draw the function. What is the shape going to look like? It's minus a half, so it's going to be increasing. It's from the bottom to the top. Okay. So it has an asymptote at 1. So do you agree I need more negative than positive? I need more negative than positive. Alright, what will the shape look like? I make the shape for myself. It's like this. at the bottom. The asymptote, what is the asymptote? You can tell me. As kies toch? An asymptote is the equation of a straight line. What is 1? Is not an equation. What is the asymptote? Y is equal to 1. Don't make that mistake. Okay, 1 is nothing. 1 is not a point. 1 is not a line. 1 is nothing. It's either a line or it's a point. Y-intercept, we let x be 0, no? So it's going to be negative a half to the power of 0 minus 1 plus 1. You just type this on your calculator. Now you can check for the X-intercept. If you see that it's something that doesn't want to work out, then you just stop. Okay? Because you don't have to be able to, let me say it like this, to get the exponent alone, if it was something other than a whole number, easy whole number, you would need logs. And you are not doing logs. You don't know how to work with logs. You see that button on your calculator, log. That's a function that you haven't worked with, okay? So it can happen that it might be there, but you can't calculate it. Then it's fine. You don't expect you to be able to work with logs and you haven't learned it. Okay. Right, so the x-intercept means y is 0. So it's 0 equal to negative a half to the power of x minus 1 plus 1. Okay, that 1 goes over, it's negative 1, but then both the bases will be negative, so I'm already going to multiply it with negative. Then I've got 1 equal to a half x minus 1. Do you agree with me? I'm just going to go on this side. You just go on underneath each other. I want to make that half. Do you remember when we worked with exponents? We don't want to work it with when it's a half. I take it up and it becomes 2 to the power of negative 1. Okay? So on this side I've got 1. This side I've got 2 to the power of negative x minus 1. Right, and now this one will be able to calculate. How can I write 1 as 2 to the power of something? 2 to the power of? 0. Therefore, I know I've got negative x plus 1 equal to 0, and then x is equals to 1. So you see how the exponent work is coming in here. So I do have an x-intercept that I can calculate. It's 1 and 0. Okay, now I'm going to draw it. Always start with the asymptote. Okay, the asymptote we said is y equal to 1. Then my y-intercept is 0 and negative 1. Have I done anything difficult? I don't think so. Nothing that we've done is something that you haven't done before. And then the X intercept is going to be there. It's 1 and 0. And now I don't need anything else because I know what my shape is supposed to be. I don't have any other critical points. No other place where this graph cuts anything else. So all I'm going to do is I join these 2 points, the main ones that I have. This one nearest to the asymptote, and then it goes down. And there I've drawn the exponential function. Already copied it as well. Thank you so much. Thank you so much. Oh, that one there. Bye, donkey. Okay, I want to do something difficult with you now. But I'm going to do it now so that you see it's not difficult. And that you will be able to remember it. 4, you forgot the straight line, eh? And yes, I'm going to ask them all together. At least 2 per question. So the only thing that actually comes in when we have 2 functions is I can ask you what are the points of intersection between these 2 graphs. Do you remember we said yesterday how to calculate that? It was the last sentence. To calculate what the points are, you will let the 2 equations be equal to each other and then simplify. Okay, I want you to consider the graph f of x equal to 2 to the power of x. Okay, before we do this, something that's also important that I noticed in the previous years, like a week after we've been doing functions, and that's shocking, is that you don't know when it's a straight line, a hyperbola, a quadratic function, an exponential function. Okay, listen to me. If the x is in the exponent, it's an exponential function. If the x is in the denominator, not if there's a fraction, it can be x over 2. Then x is the numerator. Then it's a straight line. If x is the denominator, then it's a hyperbola. If the x has a square, it's quadratic. And if it's anything else, like x is the numerator or what, then it's just a normal straight line. Okay, you just need to get it into the format of mx plus c. So x over 2 is actually a half x. You hear me? Right? Okay. So what function is this? Exponential. Okay. I want to show you what happens. They can ask you to find y equal to 2f of x. You need to find the equation of that one. They will normally say, we now have graph h. Graph h is equal to 2f of x. Find the equation of graph h. Okay? So this f of x is y, and it's the whole function. Do you understand that? It's the whole f of x. So what I'm going to do is I'm going to take the whole thing and substitute in the 2. Do you understand? So it's going to look like this. Let me just get a pencil. F of x is 2 to the power of x. But I want 2 f of x. So I put the 2 in front. And that's the equation of the new one. So it will be 2. Will it be 4 to the power of x? Why not? Normal number, exponential. That's A, that's B. So it's 2 times 2 to the power of x. All that will happen is all of your answers will double. Okay. Do you remember A is the gradient? So where your exponential function would just go up like that, when it's 2 times 2a, it would go up steeper. That's all that happens. Okay. 2 times 2 to the power of x. Right, that's the first one. Next one. See, I told you that was easy. Y equal to f of x plus 2. What is f of x? 2 to the power of x and then plus 2. So what value does this function get? What variable is normally there? Q. What does Q do? Moves it up and down. So this graph is the same as the original one, but the asymptote was moved up 2 units. So everything was just moved up 2 units. It was translated 2 units upwards. Does that make sense? Yes. Okay. Now this one, they are not saying f of x, close the bracket, minus 2. So the 2 must not be subtracted from the whole function. That bracket belongs to x. So that means the 2 must only be subtracted from x. Okay. So you're going to write down the function y equal to 2 to the power of, but instead of x, you write whatever is inside of the bracket. If it was f of 2x, you would write 2 to the power of 2x. If it is f of x times a million divided by 5, you write 2 to the power of x times a million divided by 5. What's inside of the bracket must happen only 2x. So it's going to be x minus 2. And you see, I don't take the previous one. F of x is 2 to the power of x. This was something new that I created. F of x is f of x. Okay, number 4. This is an important one. So it will be y equal to negative 2 to the power of x. Do you agree with me? This is not negative 2 to the power of x. This is negative 1 times 2 to the power of x. So where the original graph, the f of x, that graph looks something like this, nay? At the top of the asymptote, increasing. Right? This one is the reflection. It's at the bottom of the asymptote, decreasing. So it's a reflection in the asymptote or in that line. Okay. What will this one be? Negative x. So that negative belongs only to the x. So I've got y equal to 2 to the power of negative x. Is that in its simplest form? What is it? Y equal to a half to the power of x. Now I just quickly want to show you, and this is extremely interesting. It's something that you actually only use in grade 12, but I want you to notice it already and you can make a note of it. This one will now still be at the top of the asymptote, but it will be decreasing. Okay. Now when I look at this one where the negative was put in front of the y, you see it's being put in front of the y, because f of x is y. Okay? Then we get the reflection in the x. If the negative was put in front of the y, the reflection is in the x line, the horizontal line. When I put the negative in front of the x, remember the original one was this. The new one will be this. So when you put the negative in front of the x, you've got the reflection in the y. Okay. Negative in front of y, reflection in x. Negative in front of x, reflection in y. It's important. Okay, write it down for yourself. In front of x, the negative, reflection in y. In front of y, reflection in x. Now, I just quickly want to give you a new function, g of x, just to show you, equal to 2 to the power of x minus 1 plus 3. If I tell you I want to find the equation of h of x, and h of x is g of x minus 1 minus 2. I'm asking you for the equation of h. What is h? H is the same as g, 2 to the power of x minus 1. That was x minus 1 that was there. But this one has another minus 1 at the x as well. So whatever it says there, you just do that as well. If it said x plus 5, you would have x minus 1 plus 5. Do you understand that? Is it too much? You look like your heads are exploding. And originally it was plus 3, but now you must also minus 3. So all I did is, let me just show you. I took what it said at the x, next to the x, and I put it next to the x. And I took what it said after the f of x function, and I put it after the whole f of x function. So I'm just doing what they're doing. And therefore the equation of h will be 2 to the power of x minus 2 plus 3 minus 2 is plus 1. That's the new equation. And just to tell you that you actually already know all the work, they can actually ask you what happened to G. What happened to G for it to become H? What happened to G for it to become H? Okay? So what happened? It got a negative 1. So P, remember P is otherwise, ne? P got another minus 1. So what does minus mean for P? Plus, it means right. That's the word I want to know. If you minus, you move right. If you plus, you move left. So what happened to this graph? It moved right 1 unit. And what did it do, up or down? It moved down 2 units. That's a level 4 question. And you can do it after 2 days. Do you understand that? So what does P do? Moves left or right. Okay? Plus left, minus right. What does Q do? Moves up and down. Plus up, minus down. As easy as that. Okay. Alright. Let's start. I just want to think where I want to start with. Let's start with this first. Okay. This is, once again, you guys notice that I'm giving you the summary of the work after every module that we do, ne? Remember what I've said before? If you put it in your file, you haven't done anything, ne? Okay. I remember when I was at school as well, you put it in the file. Now you think you did your job, ne? You must go through it. You must read it. It's summarized. It's everything we said, and maybe in some ways said in a different way, some feeling like it's saying it better or clearer. But I think it feels like you guys are okay with the functions. Okay. We are going to start to apply it now, but you can go through it, work through it. They give examples there. And then I want you to open up on the first page where they have given you a question. Okay, before we do the question, I think I should just... No, let's do the question first, but if the bell goes, I want to get your marks as well, but I'm recording now and I don't want all of your marks to be on the video for your own sake. Okay. We'll start with question 5 of November 2019. I'm going to do it with you, okay? The first two we're going to do. You'll see question 3 and question 4 is number patterns. You are welcome to go and practice that as well. When you're starting to study for the exams that's just around the corner, ne? Okay. So question 5, it is given that f of x is equal to negative 3 over x plus 3 minus 1. Can you please tell me what function this is? You are already smarter than many grade 11s even at the end of November. And they give you another function, g of x is equal to negative a to the power of x. What function is that? Exponential. Okay. And now they tell you the point. A point is a coordinate, ne? 1 and negative 3 lies on g. So it lies on the exponential function. And that's all that they've given you. Okay. Then the first question says, determine the value of a. Who has a plan for me to determine the value of a? Do you remember when we worked with the straight line? Sometimes we had the gradient, then we had to find c. No? Sometimes we had c, you had to find the gradient. Do you remember how we did that without the gradient formula? We had a coordinate. No? And a coordinate means you've got an x and you've got an y. And then you can put it into x and y, and then you can calculate the variable. That's what's always going to happen. You're going to be able, if there were more than one variable, you would be able to read the other variables from asymptotes and things like that. And then there would be one that you can't read. And that last one you will calculate by getting a coordinate, putting it in the place of x and y, doing the substitution, and then you calculate the last variable. Okay. So, 5.1, we will say negative 3 equal to negative a to the power of 1. I divide both sides with a negative, and therefore a is equal to 3. Do you understand? 2 marks. Done. 5.2. Please read that question. What does it say? Write down the equations of the asymptote. Equations. How do I write an equation? Y equals and x equals. Okay. Who wants to try? One of you to try. Put up your hands and tell me, because there's no calculation, what is the asymptotes equations? Both of them. Don't care about? Almost. Y is equals to negative 1. Remember y and q. Yes, and then x. X is equals to negative 3 because p it changes, no? Gets the negative. Another 2 marks. You've already got 4 out of 18. Except for Nonkeva. She got 2 out of 18. But she won't make that mistake again. Alright, 5.3. Ooh, this is a nice one. I forgot I also wanted to talk about this. Write down the range. Now, with your class, we forgot to write it down on that previous page. If you have that page there, you can open up there. The first one they ask on that other page is the domain. And the second one they ask for, right at the top, Antoinette, page back, right at the top, is what is the range. Okay, so a domain is all of the x values possible. All possible x values. And the range is all possible y values. Don't confuse them. All possible x values for domain, all possible y values for the range. Okay. So they are asking you No. They're asking you to write down the range of G. Okay. I want you to imagine this function. Remember, because we calculated the value of A, we know now that G of X is equal to negative 3 to the power of X. Do you agree with that? Yes. Okay. Please tell me, see it in your mind. Is it at the top or at the bottom of the asymptote? At the top end. That's what I hear. Is it at the top or at the bottom? Bottom. Why? It's a negative. Okay. What does its shape look like? Remember, at the top, if it's positive, if it's a whole number, it goes up. So this is a reflection. It's going to start at the top and go down. Okay. Now, let's say the question was, what is the domain? Can I substitute negative infinity? Negative 1,000,000. Can I substitute negative 1,000,000 in there? Yes, I can. Can I substitute in positive 1,000,000? Yes, why not? I put in 1,000,000, it will give me an answer. I won't be able to read it from my calculator, but it exists. That's the thing, the word. It exists. The answer exists. Okay. But the question is, what is the range? So you always start from the negative. Will this graph, remember we said this graph is starting at the bottom, no? Yeah, starting at the top, going down. What is the smallest value of the y that this graph will reach? Negative infinity, because it's going down and it's got the arrowhead. It's negative infinity. What is the biggest number, y value, y number, that this graph will reach? Remember, it's going up, and then it's flattening. To what? To 0. Why to 0? Because the q value is 0. So the asymptote is 0. Do you understand that? So from negative infinity up to 0. Will it touch 0? Why not? It's an asymptote. Okay. It's an asymptote. Do you remember I asked you when we did the exponential function, what can you put in your exponent to get an answer of 0? 2 to the power of what is 0? 2 to the power of 0 is 1. 2 to the power of nothing, non-existent, asymptote is 0. There is nothing that you can put in there. That's why you have the asymptote. So when we write down the range, it will be from negative infinity up to 0. But it won't touch 0. Do you remember how to write if it does not include the value? It's the two different blocks, ne? Hakkies, not blocks. Okay, brackets. Which one does not include 0? The block or the round? The round, mamparas. The block includes. Okay. The round excludes. And do we include or exclude negative infinity? Exclude. We always exclude, because what is negative infinity? No, it is a number, but it's infinity. Okay, so it doesn't have a specific value. So therefore, the infinity and the negative infinity, it will always be excluded. Okay, then they say determine the x and the y-intercepts of f. Will you be able to do that? Y-intercept, how do I calculate the y-intercept? So I'm going to calculate f of 0. Do you agree? Okay. And how do I calculate the x-intercept? So the way we write that, we say f of x equal to 0. Do you remember that? Okay. Okay. I want you to do number 5.4, 5.5, and 5.6. So all you're going to do at 5.4 is you're going to get the x and the y-intercept. And then at 5.5, you're going to draw the two sketches, but on the same set of axes. So you draw the asymptotes of the hyperbola, and you finish drawing the hyperbola. And when you're done with it, you draw the exponential function. All right. And then 5.6, they say determine the axis of symmetry of F, which has a positive gradient. Remember, we've got two axes of symmetry. When does it have a positive gradient? If the value in front of x is positive. Okay, just the three of them for tomorrow, please. Yeah, I need the marks. Sit.